thank you very much for the introduction. And I suppose when you and I started off originally, we would have created new collagen through repair mechanisms that we still have, maybe with lasers and radio frequency, but these are the new kids on the block. So what have we got? We got exosomes that we've seen earlier, and exosomes, I suppose, work within the cell. Exosomes, in many ways, I suppose, are a bit like the COVID vaccine. They've got this lipophilic structure around them. They're within the cell. They're acting at nuclear level. They've got codes and biochemical cues that make, I suppose, gene encoding possible. And as a consequence, the new collagen is formed that way. But polynucleotides are different. Polynucleotides are really just peptides. They're proteins. And what they're doing is going into the cell from the outside. So one is extracellular, the other is intercellular. Extracellular means that they must come up to the door, knock on the cell to get into it. And they are a bit like, I suppose, the COVID virus was, because it could only get into the cell using ACE receptors. Polynucleotides use A2 receptors. So what do they do? Once they're outside the cell, they have this, I suppose, inflammatory reaction that we know that we're trying to suppress to a large extent. And they're made up of these nucleotides, aromatic compounds. They have got active free oxygen residues, and they can be used in many ways to hydrate, and they can also provide protection against UV light and mop up free radical scavengers. They do all these things, but I suppose what we're interested in today is how they work to produce collagen. So we've used them for quite a long time before in medicine with the chronic, I suppose, wounds, burns, that sort of thing. We know they've worked in sort of tissue repair, and they're involved also, as I said, in hydration, scavenging free radicals, stimulate cellular growth, and obviously the anti-inflammatory effects work by modulating cytokinin release. And I'll go into all that just later in it. So we have the antioxidative effect, moisturization, looked at to an extent. And I'll look at them a little closer, but really what I'm interested in, and I spent a lot of my life, I suppose, working on this, is how they affect fibroblasts. So I'll just quickly look again at the antioxidant effect. So that is free radical scavengers, and as a consequence, we know that this is used in many ways to protect the skin against things like UV light. That works by a reactive oxygen sequence. If you remember your biochemistry, the donator electrons from one molecule to the other, and as a consequence, stabilize these free radicals from causing cellular damage. So I suppose, DNA protection is one of the big things that we wouldn't really notice when we use them as doctors. They're very, very safe. They're coming from a safe source. And if they were doing nothing else, they provide moisturization. And they do that by this mechanism where hydrophilic polyanic structures enable them to bind water molecules. So they fill up the intradermal spaces by making the tissues firmer and more hydrated. But that isn't, I suppose, really what we're looking at. Even though this produces suppler, plumper skin, which obviously from the patient's point of view will reduce the appearance of fine lines and wrinkles. But what we want to do is more this, the wound healing repair, the effect they're having on cell proliferation, the effect they're having on extracellular matrix. And we know that exosomes and secretomes can work on cell senescence. And cell senescence is going to be a big thing in the future now to stop cells, zombie cells, from dying off, that they can remain there. And as a consequence, people can probably look younger. And we know some of the companies now with secretomes are actually moving into producing drinks, chewing gum, intranasal sprays. So that's going to be the whole new thing. So what we're looking at is how do they affect fibroblasts and how does the collagen produce them? And then I'll go into how we actually use them, the mechanism of action. So fibroblasts originate from one of our previous doctors shown that can be affected by exosomes by working through DNA sequencing directly on the fibroblasts. These guys are a little different. They're working through, they're knocking on the door, To get into the cell, they're using this A2 receptor mechanism. So A2 is like the lock and the key that gets you into the cell. And there is a good article there by Squadrito, Francesco, and Beto that showed how this works down through the different cytotomes, the cytokines, the growth factors, and as a consequence, we will get the polynucleotides working on the fibroblasts. So just a quick look at adenosine A2 receptors. What are they? They are involved, obviously, in inflammatory, reducing inflammatory cytokine production. And I think with the delayed onset nodules that we get from a lot of the hyaluronic acid fillers, that this could be a way of almost preventing this in the future. And I intend to start doing some sort of work, I suppose, on this very soon, experimental work. I'm working in medicine less now than I used to be, but this would be a good project for somebody to take up. So it's working through the A2 receptors that will promote collagen production. Now, the polynucleotides will stimulate fibroblasts, as we know, and the fibroblasts are the things that are present in connective tissue. They're motile cells that can move about the body. You can move them to reach red light. And in one of my lectures in India, I think it was, actually, I showed that where we had an electron microscope and we had an obstacle, and as a consequence, the fibroblasts, if you shone light 633 nanometers, the fibroblasts will jump over the obstacle, which I find is fascinating. They're motile sort of cells. They can be moved around the body, but we can also control them where they go. Now, they'll produce the extracellular matrix components, collagen, elastin, glycoproteins, all the things that we need to keep cells healthy. And as a consequence, we use these quite a lot for that particular reason. So they offer a multifaceted approach to skin rejuvenation by, as we said, originally hydrating all the cells, but also boosting collagen production, promoting healing, and because of their origin from the source, they're comparatively safe. And I'll go through that in a moment as well, where we get them from salmon sperm and why we do it. Growth factors are an important thing because growth factors, I suppose, are the most important, I suppose, facet really in skin repair and regeneration. We've been working with them quite a long time with where we won awards for using stem cells originally to promote growth factors that through PRP also, and we were using them for repairing burns, as you know, and for also tissue damage secondary to vascular necrosis. So this is the way that they would work there. We were looking originally at the growth factors. There's 7 of them that sort of work through the fibroblasts to produce collagen, and also, of course, cytokines, which are very, very important. Cytokines, as you know, work as signaling messengers, and the polynucleotides that we're injecting in will modulate the cytokine production, leading to enhanced healing and, of course, also reduced inflammation. So if you want to get to know these things, you've got to know the physiology of how they're operative and why they're working. And we know that fibroblasts per se can produce collagen. You see it in the right-hand diagram here. They contribute to skin texture, elasticity, firmness, and there's restoring the internal structural integrity of the skin itself. A2 receptors is the code that they sort of work through. And one of the big things, I don't know whether you know about them or not, but they really work through these GPCRs, which is G protein coupled receptors, and A2 really are part of that larger family. So they're involved in transmitting chemical signals across cell membranes. So this whole process of bioregeneration works like this. So as a consequence, I will show you now in terms of administration. This is the level that we have to inject them. So it's in the deep layers of the dermis. They can be injected subcutaneously or intradermally. Obviously, if you run them too high in the skin, you're going to be left with little sort of nodules. And they come from salmon, as I sort of mentioned, and salmon sperm DNA has been used for quite a long time. It's nothing really new in medicine. I know it has crossed into, I suppose, aesthetic medicine in pretty much the same way as Botox did originally. As you know, with Botox, we were using it originally in ophthalmology before it was used in aesthetic medicine. The same thing with PRP. It was used in dentistry and orthopedics before it was used in aesthetic medicine. And salmon sperm has been used for maybe 30 years now or more in terms of wound repair. So, I mean, that's technically how the polynucleotides will be injected into the skin like this. So they're injected down about 1 to 3, I suppose, millimeters, and usually droplets of maybe 0.1 again to 0.3 mLs. And you normally would do it as a sequence running down here, and so there's many different ways of injecting them as well, of course. If you run them too superficially, you're going to get lumping and irritation. We don't want to do that. And so the average volume that goes in is probably about not 0.05 mil. So it's finely deposits, and I find that you could easily use just a mil within the face itself. It says there a mil per side. We do that certainly as well, using 2 mils. I tend to be very flexible with their use, and even to an extent where I inject them. And do we need normally then 3 treatments about 3 to 4 weeks apart? So we can use any one of these methods of doing it. I've 15 staff here, and the nurses prefer different ways than the doctors. A lot of them are fond of linear threading, maybe even serial puncture, cross-hatching, fanning. I don't tend to do as much. So first and second is really what I have tended to use. This is the sort of injection sequence that we tend to use in the clinic for doing polynucleotides. But to be fair, I was watching a nurse doing them today with us, and she maybe put about 20 or 30 injections on one side. So there's variation certainly within it. You can get away with a 30 gauge needle, as I said earlier, deposits of 0.1 to 0.3 mil. Obviously, stay away from the potential vascular sites. Anybody who's used to Profilo, most of the injection sites also are away from vessels. Aspirate if you wish to. There's no real compulsion on it, and there isn't that contraindication below. Originally, when I suppose Chroma had given me some of these slides, they weren't doing around the eyes, but I was already doing polynucleotides around the eyes with some products that I'd got in the Ukraine back then. And again, this is just how you inject them. So you can see it's a very straightforward technique. Obviously, my differences with it compared to fillers is that the effects are not immediate, and that it means the patient come back 3 or 4 times to your clinic. There's financial responsibility as a consequence, but to date we're getting comparatively good results with them. This is the fanning technique that you certainly could use, and that is used with a 25 gauge cannula. And again, the contraindication on that it doesn't really exist anymore. Again, this is a patient being injected with a cannula. And I must say, cannulas work quite well. Take a little longer to do. It's becoming very popular now. Even with PLLA tissues, I tend to still be more old school in terms of using needles. But again, where you can see the doctor or the nurse there going through the marionette area, that's nice to be able to sort of break down that retaining ligament that sort of is causing the problem, that you wouldn't tend to be able to get the same effect from the outside per se. Neck and décolletage, of course, are used like this as well. And the needle is inserted perpendicular to the skin, and works well for skin laxity, because outside using, I suppose, a CO2 laser or microneedling radiofrequency, there are only a few things you can use here. Profilo and also, of course, the neuropeptides. um, have a role within, I suppose, the neck area particularly. And then the neck area can be very disturbing for patients because you could have worked on their face with a great result, and of course, their neck still makes them look rather old. So this is the way that you're running down the side of the sternocleidomastoid. So as a consequence, you're out of target areas of vascular, particularly when you've got the carotid artery jugular vein there. Hands, they work quite well as well. You could use cannulas or needles in the hands. I must say I tend to prefer a cannula in the hands. We've been injecting, I suppose, the back of hands now for 25 years or more. And again, be careful of vascular structures. So you can see it's a fairly straightforward technique and an easy one to do. There's no doubt about it. I tend to find that our estheticians or medical estheticians use exosomes more so than the doctors and nurses, except we use exosomes obviously post skin ablation, but the nurses and doctors would do most of the neuropeptides because obviously they're with a cannula or a needle, so they're down further. Can also use them within the body as a sort of a fanning technique, again with needles or with cannulas. So the same protocols are used throughout the body in the different areas. Loose skin, wrinkles, scars, stria, they can be used with all these. So a series of 4 treatments, 15 to 30 days apart is recommended. And it's just here, I suppose, showing some different results. That's a patient with the neck done, and you can see the improvement. This patient here who had her face treated. This patient with their hands. I must say, I would get a better result than that by using derma fillers on the hands. And just the type of doctor I am or personality that I am, I probably couldn't bring a patient back 3 or 4 times to get neuropeptides when I know that I could do the back of those hands perfectly in probably 10 minutes with derma fillers in one session. But I suppose everybody, again, will have their own favorites in terms of both exosomes, neuropeptides, and also derma fillers. I tend to be still more old school in terms of derma fillers, but I certainly would tend to use exosomes a lot on stem cells and PRP post CO2 resurfacing because we tend to do quite a lot of that. Some of the contraindications: pregnant women, breastfeeding women, people below the age of 18. That may not exist in every country, but I suppose it does in Britain and Ireland to an extent. And obviously, stay away from blood vessels. Be careful of patients with dermatitis, epilepsy, diabetes. And I suppose, Viran, I'm reaching near the end of this lecture now. So thank you very much indeed. And I hope you're having as good a day in India as we are here in Dublin. It's not raining.
Thank you so much for the wonderful talk. Yes, we're having great weather in India now. It's finally getting the summers off and finally we're getting some cold climate. But thank you for the wonderful talk. And once again, thank you for being a part of this webinar in association, IMCAS in association with FADS.